This video is going to go over how to apply transformations in the coordinate plane. Before we get into some of the vocabulary, I want us to think about what shifts can happen in the coordinate plane. We can either move a function left or right, or up or down. We can also stretch a function or compress a function. And then we can also flip the function. Also, I'm going to write a very generic form of this transformation and all the transformations that can happen. And I want to talk about that really quickly. So what I'm going to write, maybe I'll write right here. So I'm going to write A times f of b x minus h inside parentheses with b pulled out plus k. I want you to think of your function as being that parent function f of x. I'm going to call that the house. If you are inside the house, you often do the opposite of what your parent tells you to do. That's going to be a really important analogy that I use throughout this video. If you are outside of the house, then it is okay for you to jump around up and down. All right, let's talk about a vertical and horizontal shift and where we can find those pieces on this parent function analogy. If you have a function f of x and you add k to those outputs, so all the y values for f of x, you then add numbers to those outputs. That would then affect your outputs. You are outside the function. You're going to have a vertical shift. You are going to move up and down. If k is positive, you're going to move up. If k is negative, you're going to move down. If you have a number that you're adding or subtracting inside the function, well, then that's with your x's, that's going to affect your inputs. Now, there are some mathematical reasonings that you can go through to think about why this is true, but notice the text here says if h is positive, then the graph will shift to the right. Well, if h is positive, then inside the parentheses, it's going to look like x minus h. So that's where the analogy that I gave before of you do the opposite is it feels like, because it's a negative on the inside, a subtraction on the inside, that you should go to the left, but that is not the truth. The formula is x minus h. H is in this case positive, so I'm going to move to the right. If h is negative, then inside the parentheses, I'm actually going to have x plus a number, which means that h moves us to the left because h is negative in this case. Let's look at an example. I have the absolute value parent function, and I want to sketch the graph of h of x where I'm moving that f of x parent function in two different ways. Since I have x plus 1 inside my parentheses, that means I must have x minus negative 1, or that h is equal to negative 1. Both of these together tell me I need to move my function to the left one. Therefore, each and every one of these points on f of x must move over 1. Now that I have f of x plus 1 and then that minus 3, I'm saying take all of these y value outputs and then subtract 3 from them. So move down 3. And so this must be my h of x graph. We can also go the other way. So this is the square root parent function. And this is the graph of h of x, and it wants us to know, or to find, excuse me, the formula for that h of x function. Well, it looks like my original parent function would look like that for square root. It looks like the transformations are move to the right one. So h is equal to 1. And then move up 2, or k is equal to 2. Therefore, h of x must be the square root of x minus 1 plus 2. All right, let's talk about reflections and stretches. So again, I want to use this analogy about like being outside the house. So if I have a negative outside my parent function, then that's going to affect my outputs. And notice that vertical reflection here in the graph affects my y's. If your negative is inside the house, that's going to affect your inputs or your x-axis, and notice that this flips the x's. So positive x's become negative, negative x's become positive. Additionally, you might have numbers on the outside of your function. If that number is greater than 1, then your y's are going to get multiplied by the a. I'm looking right here. A is outside the house. Right, so we're going to affect the outputs. So if a is positive and greater than 1, then it's going to make your y's grow a lot quicker. If a is between 0 and 1, then it's going to still have a growth component, but you're not going to grow quite as quickly. If you notice here, that shape of the graph for 1/2 still has the same shape, but is only half as high as the original graph. If a is then negative, what's going to happen is you're going to have that same either stretch or compression, but then you would have a flip so that your positive y's then become negative y's. Let's look at horizontal stretches and compressions. Notice here, B is inside the house. Since B is inside the house, we're thinking about this in the opposite way of the value of B. In this case, if B is greater than 1, I'm actually going to have a compression by the reciprocal. Look here at our graphical example. Here is y equals x squared. I have B equals 2, and notice it moved it in. If you have a number between 0 and 1, then it's going to have a horizontal stretch of the reciprocal. And if B is negative, you're going to reflect so that negative x's become positive, and so on and so forth. Here are also some notes on combining all the different transformations. So if you have an A on the outside and then plus a K, first stretch, then shift. My personal preference is to actually write this form right here to know my stretch and my shift. Otherwise, you kind of gets a little bit sticky right here. It doesn't matter which order you do them in first, whether you do horizontal or vertical. All right, let's look at here at this last example to close us out. So if this is the graph of f of x, I want to try to graph this transformation. Again, let's work with the inside first. And I want to make this in the form like so that I know which way I'm going. So I'm going to factor out a 1/2. And I want to think about what number would that have to be so that when I take the 1/2 back in, I get to 1. And the answer is 2. Now remember, this b here, I'm going to do the opposite. So I'm going to stretch this by a factor of 2. And then inside, I'm going to shift this to the left 2. So let's do that first. I'm going to stretch this by a factor of 2. And then I'm going to move it to the left 2. All right, now let's look at my outside pieces. I have a negative outside that f of x function, and I have a -3. So this negative means take all my positive y's and make them negative y's. This says move my function down 3. 1, 2, 3. 1, 2, 3. And so that would be my transformation piece with all 4 transformations applied.